Okay, so this is a continuation of the start of the lesson on implicit differentiation, which we did today in class, which were the two examples. So first let's look at, again, the difference between implicit and explicit functions. Today we really did only look at two implicitly written functions, and then we discussed what's the difference between that and explicit. So when you're going to differentiate a function with respect to x, if a function is written as y equals a function of x, then it's written in explicit form. Y is written explicitly as a function of x. Otherwise, if you have the x's and y's mixed up together, then you're going to have an implicit function. So recall, again, from today, how we take these derivatives. If we want the derivative of x cubed with respect to x, it's just 3x squared. But if we want the derivative of y cubed, it's going to be, with respect to x, it's going to be 3y squared times dy dx. So you need that extra piece because the variables disagree, because they're not the same variable. Now, again, remember, and I'll write it really lightly, that technically we also had a times dx with this function, but you don't need to write dx because dx over dx is just 1. So this is your whole answer for the derivative, and this is your answer for the derivative, again, with respect to x. So try C. So pause here, try it, and then hit play. Okay, now I'm going to do it. All right, so the derivative of x with respect to x is just 1, and the derivative of 3y with respect to x is plus 3 dy dx. And then here's an expression that has x and y in it that's a little more complex because it is a product. So you're going to need to use the product rule. So the first thing we're going to do is use the product rule, derivative of the first times the second plus derivative of the second times the first. And then where it says chain rule, that really just has to do with the fact that you're taking a derivative of a y term with respect to x. So let's give this one a shot. So the derivative of the first is 1 times the second plus derivative of the second is 2y dy dx, again, because we're differentiating a y term with respect to x, and then times the first. And then to simplify, because this isn't being set equal to anything, it's almost simplified now. All I would say is put these couple of things in alphabetical order. So we just have what? Y squared plus 2xy dy dx. So that's how you differentiate individual terms with respect to a variable, whether the variable agrees or disagrees. Okay, and then you just want to put that all together to do implicit differentiation on entire equations. These were just little expressions, so now we'll look at So the steps for implicit differentiation are differentiate both sides of the equation with respect to x, collect all terms that have a dy dx, usually on the left side, although like we discussed today, you could always put them on the right side, that's up to you. But take all your dy dx terms on one side of the equation and move all the other terms to the other side. Factor the dy dx out of the left side of the equation if that's where you put them. And again, in class today we did this step and this step together simultaneously. And then you solve for dy dx by dividing both sides by the quantity that you have left when you factor. So you can, let's try this one. We want to find dy dx for this function. Again, you should probably pause and try it by yourself. Matter of fact, I'm going to pause, and then just when you hit play again, or when, I'll hit record again, it's all already going to be here. So you definitely do this by yourself, and then hit play and check your answer against mine. Okay, you can check your work with this work so far, and then I'm going to turn the page. Pause it or rewind if you need to. So again, I've already collected the dy dx terms on the left side of the equation. I've already factored the dy dx out, and if I could paste what I had over there. We are supposed to solve for dy dx by dividing by this quantity. So your final answer is 2x over 3y squared minus 2y minus 5. And you probably already had that as a final answer. Now, using that, you can plug 2 in for x and 0 in for y and get a slope of negative 4/5. So at the point 2, 0, your slope is negative 4/5. At the point 1, 1, your slope is undefined. Where x is 0, that's right here. It's actually 0, negative 3, but where x is 0, your slope of your graph is 0, and so on. So any ordered pair on this graph, you can plug in the x and y to that equation, and you can get the slope. And here it is again, if you want to make a little comparison. This is your derivative, and these are just some points that are on the curve, and if you plug these ordered pairs, or the ordered pair is 0, negative 3, it's not 0, negative 3, it's something else. But if you plug these into this equation, you will get the slopes. Again, it doesn't really matter what the y value is, does it? Because as long as x is 0, that slope is going to be 0. And that is the rest of the lesson. So I would say if you need anything from this, it might be just the summary of the steps of implicit differentiation if you feel like you need to write those down. So just rewind the video to that page, and that should help.